Thank you very much to the organisers for inviting me. And I really wish I could have been there in person, but perhaps another time. So I'm going to talk to you this afternoon, as the title of my talk hopefully suggests. I'm going to look at an important question. Do you have a female brain or a male brain? Or are we asking the wrong question? The key issue is that this isn't just a neuroscience question, although I am a neuroscientist. It's a question, the answer to which has real world implications for us all, especially if we're interested in technology and in women's empowerment as the key themes of the Congress. So moving on, I'll just briefly introduce myself and my techniques. I work at Aston Brain Centre, as was mentioned in the introduction, and I spend my days metaphorically rooting around inside people's brains, getting them to do different tasks and seeing how their brains change according to those tasks. And we have the standard state-of-the-art brain imaging techniques at Aston. So we have the original type of measures, the EEG. We also have much more up-to-date measures, MRI, which people will be familiar with, and rather more unusual to look at the magnetic fields associated with brain activity. And that allows us to generate these amazing images that may well be familiar to a lot of you. They've become quite popular, not only in science circles, but also in popular media and popular science as well. And to some extent, they are very impressive, and they do tell us a lot about what goes on in the brain. But one of the things I'll be talking about is that perhaps they are as much part of the problem in understanding the human brain as they are the solution. So I, at this point, would then run you through the kind of history of the last 200 years of how we got to thinking about male and female brains and the beliefs that there were two different kinds of brains. And the question, do you have a male brain or a female brain, and where that came from? But obviously in 20 minutes, I'll have to skip over that and come to the end product of those sort of 150, 200 years of scientific questioning about male and female brains. And really the chain of argument that we can look at, which is the end product of all of this scientific questioning, is that whatever it was that determined the differences between male and female anatomy, bearing in mind that at the end of the 18th, beginning of the 19th century, we didn't actually have ways of looking at that, also determined that you had a different brain. So if you had a female anatomy, you had a female brain. If you had a male anatomy, you had a male brain. Again, we should bear in mind that these ideas came or were being discussed before we really had the techniques that I now use, which allows us to look at intact living human brains in intact living humans. These kind of conclusions were drawn indirectly from looking at dead brains or diseased brains. So we need to bear that in mind. The next chain of argument was where the experimental psychologists joined in with all sorts of questionnaires and ways of measuring how you solve problems and if you are good at understanding emotions and particular cognitive skills that you had. And they came up with this nice, neat division matching the male-female brain. If you had a female brain, you were very good at empathy and understanding emotions and making friendships, etc. But you were rubbish at reading maps, for example, and they generated a whole list of characteristics of what it was like to be a female, or what you would expect a female to be like, so stereotypes. And similarly, if you had a manly brain, you weren't very good at listening or understanding emotions, but you were brilliant at kind of solving scientific problems, at reading maps. And there was, again, a whole list of characteristics about being independent and rational and logical, which characterized the owners of these particular kind of brains. And at the end of that chain of argument was what we would now refer to as gender gaps, the idea that if you had this particular brain and these characteristics, you had this particular role in society. And if you had this kind of brain and these characteristics, you had this kind of role in society. You're going to be a great scientist, an explorer, solver of problems, a great political leader, etc., as opposed to the more supportive role, which would be characteristic of the owner of the other sort of brain. Moving on then, we should say that when brain imaging actually arrived at the end of the 19th end of the 20th century, in the 1990s, we actually needed to say, okay, we have these wonderful images, we have a better idea of how the human brain works. And let's take these images and really challenge these ideas about this kind of belief about male and female brains. But these images actually got hijacked by individuals who were very interested in differences in males and females, perhaps because they were relationship counselors or they were psychologists talking about particular kind of self-help areas. So we did find that there was a kind of tide of books which took these images, used them to illustrate their books, and came up with some rather strange titles. So we were assured that if you had a baby girl, it was going to be different from a baby boy. You were assured that boys and girls learn differently. You will also, and I'll come back to this, scientifically assured that scientists had demonstrated that there was an essential difference between males and females. And as I say, I'll come back to that. And you get a whole load of other rather strange books, why men don't listen and women can't read maps, and why men don't iron, for example, and why men can't cry and men don't ask for directions, etc. So there was a nice role of these kind of books making a belief firmly established in the outside world. And the sort of granddaddy of them all, which lots of people are familiar with, is a book by John Gray called Men Are From Mars, Women Are From Venus. Men and women are so different that they could almost be from different planets. And all of these books helpfully drew on neuroscience findings, neuroscientists say, or they illustrated them with the kind of brain images I'm talking about. But unfortunately, they weren't a very good representation of science as the scientific findings that were being found. And it was clear that the people using these images didn't have a very good idea of what they were actually showing. So I came up with a term, which hasn't made me very popular with certain authors, called neurotrash, which actually said, there's lots and lots of books out there assuring you that males and female brains are different, but we need to be very careful about how seriously we take these. But we did come up with, right at the end of this century, and still to some extent, a kind of thinking that informs what we're doing now. And that is, male brains and female brains are born to be different. They arrive in the world differently. They acquire different skills because of different experiences. But this is all the unfolding of a predetermined biological program. So there is some kind of fixed, hardwired end product that if you're a boy, you land up with this kind of adult male brain, which is, as I say, going to make you a great scientist or a great leader, a man, the winner. Whereas if you've got this kind of brain, you won't acquire the same sort of skills because you haven't got the right sort of brain that would allow you, for example, to become a scientist. So you may be very good at understanding emotions, a bit emotionally labile, etc. But there was a clear difference between these two kinds of brains. And this was supported, again, by this book by Simon Baron-Cohen, which starts out by saying the female brain, so there is such a thing, is hardwired, fixed for empathy. So there's a particular understanding of what women are good at. The male brain is hardwired for understanding systems. So a clear distinction made by scientists, and also hand in hand with the kind of neurotrash books that were perhaps informing the public consciousness. But moving on, we need to say, okay, so we've got to this idea of a fixed difference in female brains and fixed hardwired. Has that actually stood up to the test of time from the moment at which we were able to look at these, our own brains in particular ways, and actually start to really understand how the brain worked? If you're interested in how brains get to be different, you get to understand that male and female brains are different, for example, and brain images should be able to show us that. So let's have a quick look at the understanding that we now have after about 30 years of looking at male and female brains. Now, I've put an iceberg here because what it seems like, if you actually say, I'm going to have a look at all of the research that talks about male and female brains, you'll find thousands, literally thousands of papers which talk about sex differences in the adult brain. You think, oh, great, scientists have proved that there are differences. And this is very popular in the public consciousness and popular science. So you get, whenever there's a paper reporting these kind of differences, it eventually emerges in some kind of popular press or the media, proof at last, scientists have caught up. But this is what we see above the publication line of water, if you like. And what I'm really saying here is that if you start to look very carefully at all of these thousands of different papers, you see that they're not telling the same story. It's very inconsistent. They do report differences, but always the same differences. And what was reported as difference in one paper between males and females will not be reported as different in another one. So we're starting to think, the story isn't quite as clear-cut as we thought. So that's what's going on above the waterline. Below the waterline is, of course, the fact that if you're actually looking for a difference, and this whole hunt the difference agenda is really what's been informing science in this area right since the end of the 18th century, you won't report any findings where there isn't a difference. So you'll say, well, I'm doing 1,000 different comparisons, but I'm going to focus on the 100 that did come out significant. And so what you don't get is an understanding that there's actually a lot of measures where male and female brains or male and female behavior is compared, which don't show a kind of difference, the kind of difference that we've been assured is evident. And just recently, there was a paper published by Lise Elliott and her team in Chicago, which looked at the 30 years, preceding 30 years of brain imaging, asking this question: how good is the answer? How reliable is the answer? And she came up with a paper which is called Dump the Dimorphism, because looking at all of this research demonstrated that if you looked at all the human brain studies which ask the question about do you have a male brain or do you have a female brain, there was actually no differences between male and female brains using the brain imaging systems we currently have. The only difference we could find was that on average, male brains are about 8 to 10% bigger than female brains. But that's actually because males are on average about 8 to 10% bigger than females. And the bigger the brain reflects that. And that if you correct brain size for the fact that, it's in a brain which has a body which has a different sized head, etc., that disappears. And you find that there's actually no reliable, consistent differences between male and female brains. I can't take 2 different brains and say this is from a male and this is from a female. I can't look at a brain image and say that's the brain image of somebody who is male, that's the brain image of somebody's female. If somebody comes to my lab, a male, I can't say I know what your brain is going to look like. Similarly, a female. So that's a very important myth, which we should no longer be believing. And the same kind of question has been asked of this belief that there are different ways of doing things. There's a male way of behaving, a male kind of personality, female way of doing things, female kind of personality, male set of skills, female set of skills. Again, looked at all the research in experimental psychology, in fact, over more than 30 years, nearly 80 to 100 years, and said, let's have a look at how reliable these differences are when we actually experimentally, empirically study them. Came up with exactly the same sort of finding, that if you look very carefully at all the research that we've been talking about, men and women are actually more similar than they are different. So we really need to get away from the idea that there is such a thing as a female brain. That's a myth. Or also that there's a masculine way of doing things or a female way of doing things. So we should dispense with the idea that boys will be boys, vive la différence, etc. But there is but into this. We did have a chain of argument which said different brains meant different people, meant different roles in society. So have the different roles in society disappeared as well? Well, sadly, the answer is no. Gender gaps, or the fact that there's underrepresentation of particularly women in some spheres, particularly science, and men in other spheres, but perhaps early years education. These gender gaps are still alive and kicking in the 21st century, despite the evidence that this doesn't seem to be related to different brains and different behaviors. And every year, the World Economic Forum draws up a report on over 150 countries, looks at gender gaps in key areas of representation, and comes up with a metric which talks about the size of each country's gender gap. And there is no country which has reached gender parity as yet. Iceland and the Scandinavian countries are closest. I'm afraid Chile is down at number 70, but I'm sure you're working on it. And sadly, it's clear that if you look at the rate at which this change is occurring over time, in 2020, the time it was estimated, the time it would take to close the worldwide gender gap was nearly 100 years. In 2021, it was estimated as 135 years, so a whole generation further on. probably related to pandemic issues. So gender gaps are still alive and kicking. And in particular, with respect to the theme of the Congress, one of the biggest gender gaps, and one that has been tackled quite actively in some countries, is the underrepresentation of women in science. And just last year, there was a big report by UNESCO who said, let's have a look at representation of males and females in science, particularly in emerging science, those sciences which are going to take us forward into the future, like cloud computing or engineering or data and AI. And sadly, this scale at the bottom shows that in those areas, the underrepresentation of women is not only appalling, it's actually women are disappearing from these spheres. So it's something we should really be worried about. So can neuroscience come up with the answer? So I have about 5 minutes left to explain this to you. And that's really to say, in the 21st century, we do have different ways of understanding the brain, which could be helpful in understanding where these gender gaps come from and how we can help the people who are affected by these gaps. And this is what I call the 3P model of the brain, the fact that there are different ways of understanding how the brain works, how it processes information, how it changes, and how it solves problems, and that understanding was not available to us until we had brain imaging about 30, 40 years ago. These 3Ps refer to the fact that our brains are like predictive texters. They're not just passive information processors, amazing that they are. They're actually quite proactive rule generators. They actually keep a record of the outcome of various kinds of information processing and generate rules, which means every time we see something new, we don't always have to process it right from the beginning. We've actually got an inbuilt set of rules or algorithms which says this is what's likely to happen when you hear this sound or see this sight, or even more complex, when you're in this kind of social situation, how you should behave. You see an emotional expression like this is what the person is thinking. Similarly, we understand that our brains are plastic, that if you remember from the developmental model I talked about before, the idea was that our brains were fixed. When they stopped growing, they'd grown to the size they were going to stay until the end of our lives, until aging and senescence set in, and the pathways were established, and there weren't any differences. So the brain you had was the brain that was going to carry you through your productive years, if you like. But we now know that brains will change all the time, even in adulthood, depending on the experiences you have. And the image here is talking about learning to drive a taxi around London, immensely complicated. We know that the visuospatial areas in successful taxi cab drivers' brains will change while they're practicing learning to be a taxi cab driver while they are taxi cab drivers. And interestingly, once they retire, those differences will disappear. So it shows that the brain's plastic, can be moldable, will wax and wane according to the experiences it's having. The other thing we know, the third P, is that our brains actually take account of the social context in which a problem is presented. So if one group is told, people like you aren't very good at this kind of problem, see what you can do, I'm going to have a look at your brain in the scanner while you're solving it. If you have another group and you say, people like you are really good at these kind of problems, I want to see what happens in your brain. You will find, and this is exactly the same task, so you will find, unsurprisingly, that the people who are giving the negative message make the most mistakes, and also that their brain processes the parts of the problem differently from those who are given a positive message, who solve the problem much more efficiently, and the parts of their brain that are activated are the appropriate parts of the brain, whereas those with the negative message, they got much more emotional interference, if you like. So we know that the brain presented with exactly the same problem will also take account of the social skills associated with it. And I won't go into all of this brain imaging findings in particular. These are findings, some of them from my lab, but demonstrating that in fact, our brains are also wired to make us social, so that it's not just solving problems. It's a bit like our permeable brains that I talked about before. If you ask somebody to ponder on their particular role in society, or if you say to somebody, I'd like you to think about when you made a mistake and how bad did you feel about that, you'll find that the areas of the brain which are activated are actually two things. They're inhibitory areas, so they tend to stop you doing whatever it is you're doing or approaching the social group that rejected you before. But they're also the areas of the brain which are associated with real pain. So this is a really negative experience. Negative social experiences are really problematic. So associated with that is particular kinds of behavior that we have individuals who show this kind of reaction in particular social situations tend to have a very poor self-image. They're very worried about being rejected. They're very critical of themselves. And sometimes they just withdraw and say, this clearly isn't for me. You know, my brain is telling me not to approach this group. And these patterns of activity are very, very characteristic of women. And there is marked gender differences in the evidence of activation in women undertaking these kind of tasks and these kind of behavioral problems, which can be in everyday life in organizations, but can also become clinical, such as in depression. So I need to move on and say that what we've learned from this is that we're not just looking at what's going on inside the brain in order to understand where gender gaps come from. We need to look at what's going on outside the brain as well. It's still a brain process, but it's a brain process which has been stimulated, initiated, diverted, distracted, if you like, by outside influences. And the kind of influences we might talk about is the fact that from a very early age, it's clear that there are gender stereotypes within our schools. So there is an expectation in schools that girls will not be good at the kind of spatial skills that are available to boys. It is assumed are innate. We also know, if we look at the plasticity of the brain, that these kind of skills, spatial skills, can be trained. So we can make perhaps females who are not as good at spatial skills equally as good as males with spatial skills. And we've demonstrated that by looking at not only sex differences in spatial processing, but also saying, if we're looking at spatial training opportunities, if we have a measure of what toys people played with and what kind of hobbies they have, we can find that males and females, this will actually wash out any sex differences. So our science experiences, if you like, are very important. And the other aspect is the culture of science itself. And I'm aware that I'm overrunning my time. But I will say just quickly that science as a culture needs to look at itself. If we know that brain activity is very much determined by the social culture in which it is functioning, whether or not the person feels that they are part of that culture, whether or not they feel they'll be accepted by that culture, whether the culture has a belief that you need to be born brilliant, not that you can acquire brilliance, or that celebrates your successes differently, that will lead to negative forms of behavior. And similarly, being a kind of social human being means we need to see role models. If we want to belong to an organization, if an organization wants to welcome us, that organization needs to demonstrate that there are a lot of people like you in our organization. We celebrate their success. We train them up to be as successful as lots of other people. And this is something where we need to realize diversity and inclusion is important. So just to finish then, in answer to the question, do you have a female brain or a male brain? Are we asking the wrong question? The answer to the question is we definitely are. We need to dispel that myth of the female brain because it has so many downstream consequences for what we believe is possible for ourselves and for our employees or our students or any kind of organization. So just to echo an opinion piece in the New York Times not so long ago, can we finally stop talking about male and female brains? And hopefully, if you're interested in this, you'll get some more evidence that along the lines that I've been talking about in this book. So I will stop now. I'm aware that I've overrun my time. I'm very sorry. And I'll stop sharing. So if there are any questions or issues, I could answer questions if that's what we're going to do.